Hello, welcome back. I'm Mr. Nyanda from Atsikana Boy Education School. I'm a math and computer studies teacher. So remember last time we were discussing about the properties of the circle, the basics before we start discussing about the angle properties of the circle. So we were discussing about the properties of the circle. Remember, a circle is supposed to have a radius, a circle is supposed to have a diameter, a circle is supposed to have a what? A chord. A circle is supposed to have a what? There is a sector as well. There is a segment. So after that, we are discussing about still on basics. We are discussing about the isosceles triangle. Why the isosceles triangle is mostly used in this topic, especially when proving the theorems that angle at the center is twice angle of the circumference in the angle in the same circle is equal to 90 degrees. So we discussed about the properties of isosceles triangle. The first property is that the opposite sides of isosceles triangle, they are equal, they have the same length. Another property is that the base angles of isosceles triangle, they are equal as well, they have the same value, right? Another concept that we discussed that time, still on basics, is that exterior angle of a triangle is equal to the sum of two opposite interior angles. That one is basic as well. It's mostly used when proving those two theorems. Angle at the center is twice angle at the circumference in the angle in the same circle is equal to 90-degree angle, right? So today I'm back. So we're gonna start proving the theorems, right? We have three. We'll discuss about three theorems. The first one is this one, theorem number one. But we use those concepts now that we discussed that time, right? So the first theorem is that angle at the center is twice angle at the circumference if those angles they are subtended from the same chord, or if those angles they are coming from the same chord. Fine. So I have this resource, this object. It's teaching resource, right? So about the first theorem, we want to prove that angle. Okay, this is a circle. This one is the diameter. We have something else here, which is the center of a circle. This line, it's a chord, right? It's a chord. So we want to prove that angle that can be from the at the center here, from the chord here, is twice angle that can be from here, the circumference of the circle, but from the same chord as well. So let me do this. Angle at the center from this chord is twice angle at the circumference, meaning that this angle is bigger than this one. This angle divided by 2 is equal to this one, and this angle times 2 is equal to this one. That's the first theorem we're going to prove there, right? So stay focused. You're with me, Mr. Nyanda. Let's do this. Fine. So let me draw a circle. Remember, I'm not good at drawing. So, but I'll make sure that my drawing is very clear, explanation is very clear. If you have a question, you can drop it down there on comment section. I'll respond. I'm always online. So, okay. So remember, I said we're supposed to have a center. So let me create a center here. Center O. Most of the center is marked O. So there's a center O there. So I want to draw something which will look like this one exactly. Supposed to look like this one, right? So we should prove that the angle at the center is twice angle at the circumference. So I want to draw something which will look like this one. So let's have radius here. Here as well. Better here. Then let me cream first. think this one is better off as compared to the first one. So let's label the points here. Let's call it A here, here B, here C, and this one is the center of. Let me make it bigger. Fine. So you can see that this one is a circle with a certain diagram inside there, right? So we're gonna prove the first theorem. That's the angle at the center, which is this one. This one is twice angle at the circumference. This one is angle at the circumference. First of all, we need to divide this diagram into two equal parts, right? Especially the inside one. So if we can draw a line from here up to the center here, up to somewhere else here, and let's call it. We have another point here, so let's call this point D. A B. Oh, sorry. Yeah, A B C D. Fine. It's fine. And this is D, not O. This is D. Let me make it clear. This is D. Now, remember that isosceles triangle will be used there, right? And the theorem that says that the angle, exterior angle of a triangle is equal to the sum of two opposite interior angles will be used there as well. It's there. So let's be together. You all know the concept. So fine. Proof. Remember, you're gonna prove, right? So you can see that from the center here up to point B, it's a radius, right? Why? This line is coming from the center here to the circumference of the circle. Remember the properties of the circle. The radius there, the distance from the center of the circle to the circumference, any point, it's a radius. So from O to B, it's a radius. From O to A, it's a radius. From O to C, it's a radius as well. So if we use this part, using triangle A, B, O, fine. Using triangle, this means triangle A, B, O. We're going to use that triangle first. Line OA. OA. That line, sorry. That line is a radius, right? That line is a radius. So, that line is equal to what? Line OB. OB is a radius as well. Why? Why OA is equal to OB? The reason is that radii. This one is radius and this one is radius as well. Radii, right? Sorry, it's supposed to be radii. Radii, right? Fine. Remember to put a reason. Why are you doing that? So this one is the reason, radii. And put 3 dots here. Not all of them, but I rest the 3 dots. Yeah, 3 dots short. Fine. Meaning also if line OA and OB, they have the same length, or if they are equal, OA and OB, if they are equal, meaning that, remember as a triangle, the first property, opposite sides of a triangle, they are equal, right? Meaning that if OA and OB, those lines are equal, meaning that the triangle A or B is an isosceles triangle, right? Fine. Meaning that the triangle A, B, O is isosceles triangle. This symbol means isosceles triangle. A triangle with this ring means that isosceles triangle. Fine. So remember the second property of an isosceles triangle. If 2 opposite sides are equal, meaning that the base angles now of an isosceles triangle, they are equal as well, they have the same value. Meaning that if this triangle A or B is an isosceles triangle, meaning that this angle and this angle, which are the base angles, right, they are equal, they have the same length. Remember now it's an isosceles triangle, right? So let's give them labels. Oh, yeah, the labels as well. Let's call it x1, this one, right? In this angle, let's call it x2. Why all of them they have x? Why? Because base angles of an isosceles triangle they are equal. So all of them they have x value. Why? They have the same value. They are equal. That's why there's x here, there's x here. Don't be confused. So let's continue. So using this part, we know that if we can take okay, in short, we know that angle OAB. We know that angle OAB is equal to which angle? Angle OAB, this one, which is x1, right? Is equal to angle OBA. Is equal to angle OBA. Reason base angles of an isosceles triangle are equal. Why? Because we have recognized that this angle is an isosceles triangle, right? So remember, base angles of an isosceles triangle, they are equal. So that's the reason here. Base angles, so angles, I will just write this one. Angles of isosceles triangle are equal. I hope reaching this far we are together. So don't be confused. If there's a question, drop it down there. I will respond. Don't worry, everything will be fine. So therefore, let's make a line here. Meaning that the value of angle OAB is x1, right? Meaning that x1 is equal to what? Angle OBA is what? OBA. x1 is equal to x2 because OBA is x2. Still more, we're still going, right? Fine. Okay, fine. Let's go this side over that now. Remember, you have this part, right? And you have this part as well. So we know that okay, let's write using triangle AOC, this side now. Using triangle AOC. We know that line OA is equal to line OC. Why? All of them. This one, OC is radius. This one is radius. They are equal, they have the same length. So let's write angle OA is equal to, sorry, not angle, it's supposed to be line. Line OA is equal to line what? OC. Line OA is equal to line OC. The reason is that OC is a radius, OA is a radius as well, so it will be radii. So, meaning that if this line OA is equal to this line OC, meaning that the triangle OAC or triangle AOC is an isosceles triangle, meaning that, sorry, here is supposed to be just a general triangle whose note is fine. Meaning that triangle AOC is an isosceles triangle. So remember, base angles of an isosceles triangle, they are equal, right? Fine. But we have this angle OAC is equal to angle OCA. Why? Those are the base angles of an isosceles triangle. But this triangle is like triangle OAC or triangle AOC, right? Meaning that we have this angle here, and you have this angle as well. So let's call this one y1. Let's call this one y2. Fine. Meaning that angle OAC is equal to angle what? OCA. OCA. Reason these angles of isosceles triangle are equal. I hope we are together. So this side, we are still that side, right? Meaning that what's the value of angle OAC? OAC is y1, right? Meaning that y1 is equal to what? Angle OCA. OCA. This angle is equal. What? These angles of an triangle are equal. Meaning that angle OCA is equal to angle OAC. Angle OCA is what? Y2. Meaning that y1 is equal to y2. Fine. Fine. We are close to the final step. So calm down. Fine. But we know that we have this angle here. We have this angle here. And we also have this angle. Right? So, this angle, which is angle BOD, is an exterior angle over triangle ABO. It's outside that triangle, so it's an exterior angle. So remember that theorem, exterior angle over a triangle is equal to the sum of two opposite interior angles. Meaning that the value of this angle is adding this angle and this angle. Exterior angle of a triangle is equal to the sum of two opposite interior angles. Meaning that we need to add this angle and this angle. Right? We need to add this angle. And this angle, let's add it. We'll find the value of that angle. Right? So let's continue. But angle BOD is equal to what? Angle ABO plus angle what? Plus angle BAO. Reason exterior angle of a triangle is equal to the sum of two opposite interior angles. Meaning that this will be exterior angle. This one is exterior angle over a triangle is equal to the sum of two opposite interior angles. That's the reason there, right? Meaning that where should I have off? Wait, I think here. We should have off here. We should have off. But remember to jot them so that we should use them later. So we need to lab off here. So angle BOD is equal to angle ABO plus angle what? BAO. Reason exterior angle of a triangle is equal to the sum of two opposite interior angles. Meaning that the angle BOD is equal to what? Angle ABO, which is x1, right? I mean x2. x2 plus what? What's the value of angle? BAO, it's x1. Meaning that angle BOD is equal to x2 plus x1. But remember, this triangle is an isosceles triangle. base angles of an isosceles triangle are equal, right? Meaning that the value of this angle and this angle, if this angle is 50, this angle is 50 as well. If it's 60, this angle is 60 as well, right? So if, let's say it's 60, this one is 60 as well, right? So if you add them, we'll get what? 120, right? What if you can just take one angle and you multiply by 2? We'll soon we'll get the same answer here if we add them, right? So let's take x1. Let's take x1 to be 60. So let's take x1 times 2. 60 times 2 is what? It's 120 as well. So therefore, we can say that angle BOD is equal to what? 2 times one of those angles, because they are equal. So let's take x1 to x1. Meaning that angle BOD is equal to 2x1. This angle BOD is 2x1, right? Fine. Let's snap off there. Fine. So let's go this side. Where that side? Let's go this side. Fine. We know that we have another angle here. Angle DOC now. It's an exterior angle as well, but of which triangle? Triangle AOC. This triangle, this part. It's an exterior angle. It's outside this triangle, so it's an exterior angle. So to find the value of that angle, which is angle DOC, we will take angle OAC, which is this angle Y1, plus angle OCA, which is Y2. Y, exterior angle over a triangle is equal to the sum of two opposite interior angles by this side, right? Fine, let's write it. Angle DOC is equal to angle OAC, sorry, this is A, plus angle what? Plus angle OCA. Reason, the dots, exterior angle of a triangle is equal to the sum of two opposite. This one means opposite interior angles. Meaning that angle DOC is equal to angle AOC, this angle Y1, plus angle OCA, which is Y2, right? So angle DOC is equal to what? What's the value of angle OAC? OAC, which is Y1, right? Y1 plus, what about angle OCA? OCA, which is Y2. Y1 plus Y2. The same procedure, the same concept here, the same method. We know that this triangle is an isosceles triangle. Why? OC and OA and OC, they are equal, right? Meaning that the base angles of that triangle, they are supposed to be equal to you. They have the same length, they have the same value, not length. So the value of Y1, right? One of those angles. And the value of Y2, this one. Y1 and Y2, they have the same value. They are equal. If Y1 is 40, Y2 is 40 as well. If Y1 is 50, Y2 is 50 as well. So let's say Y1 is 40, Y2 is 40 as well, right? So if there's 40 here, there's 40 here, add them together, we'll get 80, right? Right. It's nice. Fine. So what if we can take just one angle and multiply by 2? For example, let's take Y1, which is 40, right? As our assumption. 40 times 2 is 80. The same value. If there's 40 here and 40 here, if you can add them together, we get 80, right? So here the concept is that we can just take one angle here because all of them, they have the same value. Just take one angle and multiply by 2. The same answer, it will be the same answer here, right? So it will be like angle DOC is equal to what? 2 times one of those angles, but let's take y1. Meaning that angle DOC is equal to y1, right? Meaning that if you can multiply, if y1 is 40, so 40 times 2 is equal to 8, right? So remember those angles, they have the same value. If y1 is 40, y2 is 40, add them together to get the same number, which is 80, right? The same value, which is 80. So this one, 2y1 is the same as the result that we can get here. So don't be confused. Fine. So let's finish. Let's finish. So angle BOD is 2x1. Angle DOC is equal to y1. DOC is 2y1 here, right? But what about the value of the whole of this angle? It's like we can add this angle BOD plus this angle DOC, right? Fine. Angle BOC is equal to angle what? DOC plus angle what? Plus this angle BOD plus BOD. Meaning that the whole of this angle, to find the value of that angle, we need to add angle BOD, which is this one, plus angle DOC, which is this one, to get the whole of this angle. I hope the concept is clear. Fine. So, meaning that angle BOC is equal to what? What's the value of angle DOC? DOC is 2y1, right? 2y1. Then plus this one, right? What about the value of angle BOD? BOD, which is 2x1, is 2x1. We are close to answer. Engineers, don't sleep. Remember, we are here to solve problems. Fine. So this one is just a preamble. Fine. So you can see that 2 is common here. 2 is common. We can factorize, right? Meaning that angle BOC is equal to what? You need to remove 2 here and here, right? 2 is like a coefficient now. So it will be 2 bracket 2 into 2y1, y1 plus 2 into 2x1, it will be x1 bracket. So here now, angle BOC is equal to 2 times y1 plus x1. Remember we have x1 there into y1. y1 is this angle, x1 is this angle, right? But angle BOC is this one, the whole of this angle, which is angle at the center. But if we add angle y1 and angle x1, it's the angle at the circumference now, right? Meaning that angle BOC, which is the angle at the center, times, or angle BOC is equal to 2 times angle x1 plus x2. Meaning that the angle, the whole of this angle at the center, if we multiply by 2, we'll get this one. That's the concept there. If we multiply this angle, y1 plus x1, this angle at the circumference here, if you multiply by 2, we will get the angle BOC, which is the angle at the center. Therefore, angle at the center is twice angle at the circumference. This angle at the circumference times 2 is equal to angle at the center, right? I hope you get the concept from this theorem. So the next lesson we need to do together. Thank you for